What are you talking about?
Does anybody like Detroit Become Human?
Yeah.
All right, so we are going to do our we're doing our 4.6 notes. Again, the notes today are just proofs, okay? And I think this will help us with writing proofs. Sometimes we don't know exactly what we're going to do, but we just kind of start moving in a direction. Every proof that we do on this test, the written part or the online part, we're going to always end up proving what at some point?
Triangle equals triangle.
A triangle is congruent to a triangle.
Why do you not have a title screen?
Because I didn't have enough room. And I learned my lesson that if I made these small, then they're like really, really hard to work with. So I made them as large as I could. So yeah, we're going to go ahead and prove this first one. You can work backwards. You can work forwards. You can throw whatever you need to on there and then figure it out. In respect to a nice looking proof, it only needs to be nice for the grader because it makes it easier for me to grade. It's a little easier to logically to understand. But you can have it all mixed up as long as the last thing given or the last thing you say is what you're trying to prove. Okay, so what I mean by that is that if you're going to use side angle side, it's really nice to the grader or the person reading the proof if it goes, you tell me sides first and then tell me the angles and then tell me the sides. We're doing these together. Was that your question?
Yeah.
Yeah, we're going to do this together. So the first thing I want to point out, when I was looking at these last night, I kept forgetting this one bit of information that was really messing me up, and that's
How do you make these? Like, do you make them or do you copy them somewhere?
yeah, a lot of these come out of the book. Okay. Yeah. It would take me a long time to make one of those, unfortunately, with the software I have. But so we need to prove, first of all, let's understand what we need to prove. We need to prove that this side here, okay, is congruent to this side. That's our job. And if I can prove that this triangle right here, okay, do you see that triangle is congruent to this triangle, then I can say that those parts are congruent because of cats, puppies, cats, puppies, cats.
Turtles. Let's see.
Okay. You have a question?
So if you drew a line from X down to the bottom line and up, you could just reflect across that line and have it.
It looks that way.
But you have the same angle down at the bottom. And if you fold
Interesting.
the paper, they meet up.
But you don't know that how long this is compared to how long that is.
But we know they're congruent.
How? Well,
It says they are. Oh, it doesn't.
Prove it.
okay, so do you guys like the backwards method or do you like to just start throwing stuff out?
Start throwing
Stuff. Okay. So
start with
There we go, that's matchup.
so usually what usually happens. Okay, it's very common. Hold on one second. It's very common in these that we want to prove different triangles. So it might be that we want to prove that this triangle is congruent to this triangle or something like that, okay, along the way. Go ahead, somebody. YZX, angle. YZX is congruent to angle. Thank you. WVX, and how do we know that? It was given. What else? So right now, I'm almost thinking we can prove this triangle
Yeah.
pretty easily, actually. It's congruent to this triangle.
YZD is similar to WBY.
Okay. Y angle.
Oh, wait, WB.
Okay, so you're saying this one right here?
No, like it's like
No,
like
the
an
whole
L and
thing.
an L.
Yeah.
You want to do that? Okay, so YZV is congruent to angle.
That's given.
It's really not, though.
Yeah, it is.
Yeah, it is.
It's a line.
There's
a big
the
arc.
entire line
You can do
across the
X,
whole thing.
No, that's not
V
necessarily not
is
the whole
congruent
thing.
to
Yeah,
L.
it's VB.
It's a two angle versus one angle arc, right?
But
So
isn't it
it's not given because what you really need to say, so you're saying that this angle, because that angle is congruent to that angle, and that angle is congruent to that angle, then the whole thing's congruent.
Yeah, so we need to say that,
XVZ.
XVZ, and then you add them and then angle addition. What?
XVZ is congruent to XZV. That's given. Okay. And really, this should probably be down below this in the order. And now that we say that, we can say that this is congruent to that because of what?
Angle addition.
Angle addition.
Can't you say triangle XVZ is isosceles because the definition of isosceles?
XVZ, yes. So, well, okay, yeah. So triangle XVZ, slow down. Okay, sorry.
Why do we need that?
It's going to actually be really, really good.
There's no questions here, Connor.
Yeah.
Prove that triangle WVX is congruent to triangle YZX. You
That's-
stop
yeah.
there, you don't have to prove the
Yeah.
complete triangle.
Yeah, I thought
So my initial thought of the big triangles, we can actually just prove this triangle congruent to this triangle.
and after you prove the triangle, you just do the
Okay,
CP,
continue.
Yeah.
TC.
Mm-hmm. So triangle XVZ is isosceles.
And then by like the definition.
Okay. I just murdered the word isosceles. Someone help me with that.
ISO.
ISOS.
That's the triangle.
S what?
How about we just use my phone? SOS.
Why not mine?
Well, use your phone then, Brody.
That's what I thought.
Not
So triangle XYZ is isosceles. How do we know that? It's not really that. How do
Because it said if like the two angles are congruent, that means these are congruent, so it's isosceles.
okay, so that theorem that said if these angles are the same, okay, actually the theorem said if these sides are the same, then the angles are the same, and that was the isosceles base theorem. But we have the basis, and we're going to say that the sides are the same. So we're going backwards, so we got to use what word in that?
Isosceles. Wait, no, the other word up here.
So we have to say converse of isosceles base theorem. Okay.
I would have never guessed that, honestly.
And if you had said isosceles base theorem,
I would have said isosceles.
I would say the
you
definition-
probably would have gotten away with it. Probably would have gotten away with it. Yeah.
Then can't you say that X to Z is the same as X to B?
Yes. Because of that, we can say X segment XV is congruent to XZ and Y.
Isosceles base theorem.
Now we've already said that this is an isosceles triangle. Definition of isosceles triangle.
So we have an angle and a side.
We have an angle and a side. We just need what?
Another angle or a side.
There's one just sitting there.
Isn't it
Angle X Z E is congruent to angle Y X Z.
We've already said that. You're talking about this one?
Yeah, it's congruent to Y X.
But that's a different triangle. We need an angle inside the small triangle.
That is inside the small triangle.
Y.
Y X Z.
Y, X, okay, I misheard you. Angle Y, X, Z is congruent to W, angle W, X, B. And what makes us allowed to say that? Yes.
There's no B.
D as in Vivian.
Vertical angles. I can never remember if it's a theorem or a postulate. Okay. A theorem is like stronger than a postulate in terms of being proved. A postulate means that you kind of just accept that it's true. 1 + 1 is 2. Everyone accepts that. That's a postulate.
Apparently 2 +
So then
2
basically all of math is just a postulate.
How?
Okay, we do that when we clear.
If you use theorem instead of postulate on a proof, I'm never going to mark that wrong. Honestly, if you just said vertical angles and didn't even put the postulate or theorem, I think I would accept that as well. Okay, so now we have that this angle here, and I have to use 3 little arcies.
Triangle. When you do triangle XBW.
Triangle XBW, congruent to.
Triangle YXZ.
You got it. You want to use the same letter.
Yeah.
Okay, I'm listening.
So XZY.
XZY,
That's ASA.
and that is angle side angle.
And then we do.
And then segment VW is congruent to segment ZY because the corresponding parts, of course, of congruent triangles are congruent.
Corresponding parts of congruent triangles are congruent. CP, CTC.
All I know is that CBCCC.
Congruent triangles are congruent. I just know that there's like a lot of C's in there.
I know there's 3 C's in P&T.
You know, there's like really nerdy or really obscure references to things, and only certain people would know it.
Yeah.
So I think we should have a T-shirt that just says CP, CTC, and geometry nerds would be like,
Or people that don't like geometry would just hate the shirt.
Yeah.
they'd be like,
Bless you.
they'd probably think it's like some Russian thing or something. No offense.
That Russian color for nukes.
Or how obscure would this be if the shirt had a cat and then a puppy and then a cat, a turtle, and then a cat?
I
Boom.
was looking at 3 cats, they all different. Like
3 different cats?
puppy, camel, turtle. Kangaroo spelled with a C. Camels and chickens. Then it's just camel. Kangaroo spelled with a C.
Camel, turtle.
Just like
Chicken.
cats, puppies,
Camels and chickens.
That's all you need.
Doesn't need to be 3 cats.
Cats, puppies, camels, Kit Kat,
Turtle,
turtle,
chicken.
chicken. Oh my god, I'm trying to.
Ready.
I was saying that a week ago.
Or we could just.
A week ago, I was literally saying that a week ago.
Here's so I really don't want you to have it memorized as cats, puppies, cats, turtles, cats. But I think once you realize that C stands for congruent, then it just congruent. What's the P? Parts. Congruent. Triangles. Congruent.
That's how I remember it.
Congruent parts. Congruent triangles are congruent.
That's like really repetitive.
So let me ask you this $1 million question. Does that make us feel a smidget better than about the proofs? If that was on the test.
Yeah, I think so.
No.
You do or you don't understand? All right. So the next proof, we are trying to prove that triangle, okay? And you can see that I struggled with, Brody was mentioning the computer. I can't even make a triangle symbol. That's why it says the word triangle. But we want to show that BFE, don't tap please, it makes me crazy. BFE, this triangle here, is congruent to triangle CEF.
Wouldn't it be so much easier if we just made with this stuff?
It might not be drawn.
Well,
Well, if it's not drawing scale, it would still be the same length.
Okay. So you know what? Let's make a road map. Hey guys, listen. Excuse me. Okay. All right, so let's try to make a road map, okay? So if we're going to try to prove those congruent, first off, someone pointed out that they can show me that this is congruent to itself. So I'm gonna do that. So I'll have a side, okay? What else can I do?
Prove that
CED and BAF are congruent.
So prove this triangle is congruent to this triangle, and what will that do for me?
it'll give you that CE is congruent to BF.
Yeah.
So I'll try to prove that this, and I'll use 3 dashes because I have to, is congruent to that. So then we'll have side and a side, and we'll need one other thing.
And then we can get an angle from FEB. From FBE.
FBE. Okay, how would we know that?
I don't know. Because you figure the thing out. Figure the thing out. Get to that.
You do geometry stuff.
Here, just can we figure out what angle we can get at the end?
Okay. Do you want to just start driving?
Yeah.
Okay. So I think, and there might be an easier way because the last one I said something and there was an easier way. I think that we can also prove that, where did it go? That this triangle is congruent to its partner on the other side. And then if I have that, then I'll know that this side is congruent to this side. And then I'll be able to use side, side, side.
You can prove that they're equal because of side angle sides.
Yeah.
Outside
triangles, side angle side. I already
You can already prove that those are equal because of.
Right, because the side
Right
angle side.
before it.
So should we? Okay. So let's start by proving that this triangle is congruent to this triangle.
You have to do a couple things before
Okay.
you do it.
So let's say angle A is congruent to angle D. Why am I allowed to just use one letter there? Okay. And how do I know that? Okay.
We also know that C to D is congruent to B to A.
CD is congruent to BA.
Which bugs me, but
Why does that bug you?
because they're in the wrong order.
A, B, C, D.
You said it.
I know. but it bugs me.
it though. Question mark.
I mean, I honestly would have gone AB is congruent to DC, but
AF is congruent. But still,
A, B is congruent to CD.
AF is congruent to if we say AF, then we should say what? we should say DE.
Exactly, you have to keep something in order.
And therefore,
Therefore, triangle ABF is congruent to triangle EBC.
We don't need to do that.
I agree, but you said it in the wrong order.
Okay.
ABF.
Oh, yeah, never mind.
Okay, how do we know that?
That is angle, side, no, angle, side, angle. No.
Side angle, side.
Wow.
Do you know why?
Well, the way we have it listed is angle, side, side, so like, I'm trying to think real quick.
Oh, yeah. Oh, you're right. So we didn't do ourselves a favor, but it's side, angle, side.
Okay.
So if I was reading this proof on the test, and I hate grading these because you could have those everyone could have those in any different order they want, and I would have to find it and say yes and okay.
Now we know.
Oh, I forgot my triangle mark.
Then we can say that B to
Mark.
F. Now
Now
that
we give us more.
BF
BF is equal to C congruent to C because of congruent parts of congruent triangle.
Oh, nice.
I would say it's a secret that I know.
What?
Why do I laugh like that?
C.
So now we have one of our, I'm going to go ahead and put a big capital S out here because we have one of our sides. We need two more sides.
FE is reflexive.
Okay. So FE is congruent to FE because they're reflexive.
Ew.
There's tissues, or you can go to the restroom. It's up to you. Or there's not. I lied. There's paper towels, or you can go to the restroom.
Oh, God.
Okay.
He's blood.
I'm listening. What else?
Wait, it's like a side.
So, and then.
Isn't that a side?
That is one of our sides. Yes.
Hold on, how's that? Oh, never mind.
But we're also going to use that because I think we're going to show that this big triangle is congruent. Please.
Okay, so then you'd add A to F. Could you do an A to E?
Okay. AF plus FE
Is congruent to,
AE.
yeah,
Okay. We can say the AE.
because of angle,
Segment.
Yeah. Segment.
You probably get away with transitive, but you could also say segment addition.
Why can't we say AE is equal to DF?
Because
Because you have
we
to
have to
prove
add.
that those two, that whole line. You have to prove
And so that would
whole
also
line is.
mean that D to E plus D to F. Yeah, D to E.
Dude, I don't know how you write this down.
D to E plus E to F is congruent to.
And then,
Wait, is that a B?
segment addition plus.
It's a D.
And then that means that.
Wait, hold on 1 second. Pause.
Is that EF?
Where?
Like,
Yeah, I'm sorry, that is an E.
EF equals DF?
Yes.
No. Smooth.
I'm like,
And then A to E.
How about you sit up?
If I sit up, my hair's gone.
Congruent to D to F.
I'm not putting my hair
Sit over
there. You can go sit wherever you want if it conveniences you so much. You cannot because your hair.
So now we can do A to E. Because of substitution, right?
So
Because haven't we already stated that the other things are congruent?
yeah, okay. So we need to show that these two parts are congruent to each other. I don't think that we have enough information with just these two lines to say that they're congruent to each other.
But we know.
But hold on, I know. But just listen. So what we're going to say is we're going to go ahead and say that AE is congruent to DF. In a sense, we're kind of saying these are the same as each other. Those are clearly congruent. We said that. And we also said that these parts are congruent. We said that up there. This is the only case where a flow proof kind of helps, because you would draw arrows to those two things and say, see, that's what I'm referencing. That's why I'm allowed to say that. Okay? But once you've said it, you don't have to say it again. Yeah.
If we've already established that DF is equal to CE is congruent to CE, then that just automatically already know that it's congruent.
Say again. DF is
DF is congruent to CE, and F and E are the same line, so we already know that it's congruent.
BF.
DF is congruent to CE because of CPC.
Yeah.
We already know that.
Yeah.
BFE is equal to CEF because.
BFE, the angle?
Yeah, because that's what we're supposed to be proving.
The angle?
No.
We're trying to prove, it's a triangle.
We don't have the.
Triangle
How
BFE.
does EF congruent to CE?
Hold on, pause.
It isn't.
B.
We don't have enough information.
Okay, so how do we know that AE is congruent to DF? What rule says that we can do that?
Segment addition function.
No?
No, substitution.
Substitution.
Substitution addition.
Okay? Because basically we substituted these parts for each other to say that they're equal.
Okay, and because we can say,
So that's our third side. That's this
yeah, so we can.
is congruent to this. That's our third side.
So then we can say that the whole triangle is congruent to the side angle side.
No, it's side.
No, it's side angle side.
There's three sides, so.
No.
Don't argue.
Actually, I like that you're arguing.
Well,
One of you is right and one of you is wrong.
couldn't you say
Who's
that?
arguing? How is that our third
No,
side?
no, couldn't you say that A, the B, the E, that triangle A,
wanna
B,
know
E
what I
is
think?
congruent to triangle
No, because
D, C, F?
I swear to God, Matt, what the heck?
Yeah, because that's not our third side.
Yeah.
That's not our third
That's
side.
not a third side.
Oh, I messed up.
You just pulled that out of nowhere.
But
You
then,
did.
since they have
Yeah,
the
it did.
same thingy, that means.
Wait, hold on. I'm sorry. This is not the right line. My bad.
Yeah, so triangle
Thank you. Triangle
ABE
ABE
is congruent to DCF
DCF.
because of side angle side. And then that means that DE
Then that means
is congruent to CF because of congruent versus congruent triangles or congruent. And
B.
then-
You're going way too fast. You're good, but you're going too fast. So BE is congruent to CF.
These corresponding parts of the triangles are congruent.
Yeah.
And then triangle.
Pause.
So you want, since the final thing is the triangle, can I squeeze that in? Like,
That is the final thing. This is the last. The next thing is the last thing.
I thought SAS was the final.
No. Then it goes up here. That's why I started writing up there. Unfortunately, we ran out of room.
And then
And now I have side, I have a side, and I have a side. So now I can say,
DE is congruent to triangle CF because of side by side. Yeah, CEF.
So I was right about triangle side.
yes,
Yeah.
you were, yes.
there, yeah.
Yes.
Why?
I knew I was right.
Maddie complaining if she did all the work.
Before
She's not complaining.
Because
Before you
I
start, I
got
said
this
this
one
might be a
first
side,
time,
side,
and
side,
I
side.
didn't really- It honestly depends on what we're proving.
I took it off.
I did not prove the first one. I proved the
So I want to recap.
Stupid hacker.
This one was pretty complicated. It wasn't complicated, but it was long. Maybe it was complicated. But what made this one so complicated is I had to prove this triangle congruent to that triangle. So then I could say all their parts were congruent. And that gave me this one side. Then I had to prove
You have to get all three sides before you can do it. And you have to prove two different triangles.
Then I had to prove, right, so I had to prove these two triangles were congruent. Then I had to prove that this big triangle here
We have to prove the
Was
reflection first.
was congruent to this triangle here.
Mr. McCollum, you have
Okay,
to do
within that I had to show the reflexives, okay? So to prove that triangle is congruent to that triangle, okay? And then once I could prove that, then I could say their parts were congruent, meaning this and this, and then I already had that through reflexive, okay? So we had to prove 3 different triangles congruent before we could do we only needed to prove the third one, was our point, right?
Why can't we just reflect over point G?
Because we don't have the information to prove that everything inside it is the exact same.
Yeah.
Why can't you
Like
just
angle
go
G,
for
C,
experiment?
D could be different than
Just
angle.
experiment until you find it. Try it out.
So, I mean, this geometry is a practice in logic, okay? If I was building this thing, okay, and I turned to my crew and I said, well, yeah, of course, when parts of the triangle are congruent, they would probably just walk away from this. So you might build this by using reflexive or other things, but this is the process of the logic of being able to prove it.
There was a way easier way to do it.
What was that?
We didn't have to prove the 2 big triangles. We could have done this 2 small triangles in the end, reflexive, and then angle BGF is congruent to angle CGE because of vertical.
And that would have been,
And that would have been angle side side.
angle side
Oh
side.
no.
You can't do angle side side, Johnny.
We can only use angle side side if we knew that angle was what.
90 degrees.
Which we did.
We don't have numbers.
There is 90 degrees.
But we can't prove it. It could be like 91.
I think it's 54.
90 degrees.
But you don't know that.
Yeah, you want to-
Somebody grab me a pressure.
If we're not allowed to do something to
90 degrees.
well, 90, then why are we allowed to
See,
do
that is-
something 180?
Okay.
Yeah, I mean, that is a good point.
Okay, yeah, because I guess the line is always 180 degrees, so you assume that.
But still, it could be a teeny bit off.
Well, then they can suck it.
It could be like 90.
What is 90.00021?
Okay, so you're telling me that all of them look exactly like right angles, and then they're like, and like it's like a 360.
But then
It's
it
not
could
180.
possibly
We
be
could
like,
possibly do
could possibly be something
So,
Yeah.
2 things I want to say. One,
That's just take 6.
No.
One, very good point. For some reason in geometry, we accept when you see a line that's 180 degrees. Okay, that's the only angle that we accept, is that this is 180 degrees here, that's 180 degrees there. But you're right, it could be just the slightest bit off. If I were to build this with my, on like Microsoft Word, it could be just a smidge off, right? And you can't, you only assume 180 degrees. That's the only ones you're allowed to do. Okay? I have to have a symbol there. And honestly, that isn't 90 degrees. I mean, I can look at it.
Yeah, I can look at it.
That angle, yeah. that's-
Then that would be
Because you have all your like lines on it. Like, look at mine. It's clean.
The second thing I want to say, and I've already said it once, but we're getting hung up on, why don't we just do it this way? Well, this is a practice in logic, okay? The practice of, if this is true, then this is true, then this is true, then this is true, then this is true. Okay?
He's explaining something.
I always like to also use the analogy of like a court case, okay? So when you try to prove that somebody is innocent or guilty of something, you put all this evidence out there, and if you make so much evidence out there, then you just, okay, I agree. So you're telling the story, and since you say, do you agree that this is the same as that? The person's like, yes. How do you know? Well, it says it. It's marked there. Do you agree that this is true? Yes. How do you know? Do you agree that this is congruent to? Yes. And you're walking us through the logical steps that says, this gives me this, gives me this, gives me this. The last one just happened to be how many steps? 20 steps, or however long it was.
So,
Well,
no
what
matter-
if it's one of those cases where, like, all the evidence says that it's one thing, but it isn't? Because, like, all the evidence is good. So, like, all the evidence is towards it, but the person innocent of it, like, almost on side, how there can be a difference and exceptions. So, is that what you mean by, or it's usually like a court case?
Well, this is going to be a court case where
Yeah.
you can't deny that it's true. Okay, that's what I'm. But in terms of telling a story, that first you believe this is true, yes. You see that this is true, yes. You see that this is true, yes. Okay. In a court case, there's always there's a little bit of, I don't know, right? I don't know, video cameras and stuff now, and tapes people, right? Here I go up and I stab somebody and it's on tape. You go, that wasn't me.
Okay, Mr. McConnell, you could have.
Yo,
ever
what's up?
different.
No, he's a short
You
kid.
know all of that. But all of
What if we
the
did a
things-
vlog
it was
about
Maddox.
murdering
It was
somebody?
definitely Maddox.
the things that were stopping.
Story time. Investigation.
Yeah, my wife loves Dateline, which is almost always the wife that kills the husband. She loves that show.
Oh my God, I
We
watched
also
one,
watch-
and it was
Oh,
like,
oh, simple.
They put a
We're
guy
going back.
and then he was like just died.
The next show is gonna be about you and your wife.
Yeah, his wife just killed him. But
You watch
Yeah, so like, you know how we said F to E is congruent to F to E?
Yeah.
So just like, no matter what line you can say that.
Yes.
Yeah.
So if you ever get stabbed in the bed, is your wife?
Yeah, either.
So we should tell your wife if you ever get stabbed in your bed.
I think so.
Okay.
No, I would.
You what? If I ever get stabbed in my
Hold on.
bed, that is.
The matter for your life.
Mark, you have the floor. License, please.
We don't have F to E equals F to E. Would we be wrong in this whole thing?
Yes.
What the heck?
So can we just go, so I'm never wrong, I said A to B is congruent to A, B, A to F. F to
Yeah.
E,
What are they saying?
And you just
I would
write every
never
single
I
line
can
down.
prove every single of those, and I.
You just have to write every single line down so we can never be wrong.
If you eventually are.
So, so here's the weird thing, right? When I taught this, the not double accelerator, okay? There would be kids that for this proof, because they know that there's partial credit, they would write AB is congruent to CD given. They would write AF is congruent to DE given.
Yeah.
They would say angle A is congruent to angle D given. And they'd say, how many points did I get?
Oh, that's
smart,
Okay.
honestly, yeah.
That's above.
And if they sat close to you, I would hate it because then that person would also write AB is congruent to AB. CD is congruent to CD. FC is congruent to FC. And they would just put this whole laundry list of stuff. Having no idea what they were doing. Okay? Your drug stop. Makes me crazy.
I didn't do it.
You did do it. So you're driving to Cleveland, right? This person essentially has a blindfold on and then she's driving and says, let me know when I hit Cleveland, right?
Yeah.
How many points, how close did I get?
Very
Yeah, you got closer.
Well, he's gonna drive before he
You
gets
got
there
closer,
because
but
he
you're not
drives
there.
blind.
You went south.
There could be a stop sign, there could be
Okay.
a red light.
Okay, tell me when we get to
Driving
Cleveland.
off of
You're
the
almost
road.
there.
That's very.
Oh, wait, you
dangerous.
gotta turn around. We're heading south. Wrong way. We're turning around.
Let's do
No
one
one's
more.
there.
If we were trying
Wait, now we're
to
heading
do
west.
B, A, E, and C, F, D,
Wait,
we wouldn't have to do
you
it.
are.
Triangle is everything.
Triangle, yeah.
No,
Yeah,
It's
A.
facing yourself on
So we have the side angle and side, so like
We're going the wrong way.
there.
Yeah.
No, but you said.
Yeah, so I mean, right.
You're gonna do it back.
If I was just trying to prove that very simple thing, it would be.
Because some people try to
Well, that got complicated because of what we had to prove.
I know we had to prove the triangle is the same.
Travel from
They
Columbus.
put all that crap there and just like prove this triangle, we like think we do all that, but it's really just right there.
Yeah, sure. All right, let's do the next one.
Ends up running Canada.
Yeah. What's the French Canada?
Can we do the one? Can we do the one on the right?
Sure.
Can we do Canada?
Can I go to bed now?
We're doing the one on the right.
Because like.
We have about 15 minutes.
Yeah.
How is this
All right,
a lot
so-
easier? What?
You do or don't?
Yeah.
Okay.
So it's like angle R is congruent to angle B, and then SR is congruent to Q. I have that.
Let's do this. Let's write out on the shape what we can prove. Okay, we're not going to write any statements down, and then we'll do then we'll write all the statements out. Okay, so we're going to try to have more of a roadmap. I think some of us are just sitting here watching as a couple people are saying, now we do this, now we do this, now we do this. Okay, so we're going to slow it down a little bit, but we're going to say what we can show and why. Let's start by figuring out where we need to end up, which is that DGE triangle, that this one right here is congruent to this one right here. Okay. Now, right off the bat, I have this is one of the sides of that triangle. Okay, and this is it, but we're going to have to use this little chunk right here, right? We're going to have to use this. We want to show that this side is congruent to this side over here. So, but we're going to have to use this chunk. Okay, do we see it? Pause, slow down. Okay, so then we would have a side. Okay, and then I'm going to point out that we can say that this is congruent to this. Why? Because this big triangle is isosceles. So if this is isosceles, then we can say that their base angles are congruent. So there's our angle. Okay, so we're going to end up using side, angle, side. We just now need to go through the steps. Now we need to drive there. Okay, so first off, we can do the givens. Okay. Okay, so DE is congruent HE given. And that's going to actually be, I'm going to go ahead and put this out here. That's going to be one of our sides to our final triangle. So I'm putting that there.
We also like have to reflex it for FG, so like we can
Yes.
But you do the other one first. You do the other given first. So you get
It doesn't matter what order you go in.
So we say like DF is congruent to HG, and then we do DF plus FG and is congruent is equal to
Oh, we have to do FG
FG
is
equals FG.
congruent to FG.
Okay.
DF is congruent to HG.
So we have 13 different cars, right? And there are 13 different ways to get to Cleveland. Okay. So, and I know, so yeah, so there's 13 different ways. I'm going to just show you the way I would drive. Okay. And you can tell, and I'm going to prove to you. So I would say next, I would say that FG is congruent to FG because of reflexive. And then I would say that DF, let me do it. plus FG is congruent, this is how I want to do it, to HG plus FG. Okay. Now I feel like I should have slipped in there and I didn't. I should have said DF was congruent to HG, probably right here, which was a given statement. This is, I'm going to call this, yeah, I'm going to call it, I wasn't sure whether it'd be segment addition or substitution. Okay. And then I'm going to say that DG is congruent to HF. And I'm going to call that segment addition. Thank you. And that's helpful because that's one of my sides I want to have.
Well, now that we know it's isosceles, right?
We knew isosceles at the beginning.
So that's how we put like.
So angle D is congruent to angle H because of isosceles base angles postulate. Okay.
It's given.
That wasn't given.
Oh, okay.
And that was my angle that I wanted to use. And even though I did that in the wrong order with this, you know, someone might say, oh, that's side-side angle. Okay. I just didn't write the proof as pretty as I could have. And it honestly, if I was writing a textbook or if this was my final exam or something, I probably would reorganize the order of this to make it a little nicer looking, but I don't have to. So now I can say that triangle DGE is congruent to triangle HFE. Absolutely. And that is side angle side. Now that one, the reason that one was a lot easier because I didn't have to prove 3 triangles were congruent, 3 sets.
We're done.
There's one more triangle.
Well, I think we can do it for fun, see if any of us get it right, like see if we can do it
Can we do
ourselves.
it by, can we do the one on the
And then
left?
if anybody needs help, they can call me, that way the ones who know how to do it can get real fast.
I actually know how to do that one.
Or like people can do.
All right, so the one on the left, we'll go. I had 2 more for a notes challenge, but I'm not going to throw those ones at you yet.
Thank you.
But we're going to do this one here on the left. Yep. We'll go ahead and do it by ourselves. Sure. A what?
Colored Sharpie or pen.
You want to use my red pen?
Sure.
Sure. You can use that one right there.